These are the 10.2, 10.3 arc and chord measure notes for geometry. So here we have, in the beginning, what we're going to do is learn about arcs and learn about chords and what we can do with them. So the first question here is how do you name an arc? So you name an arc with 2 or 3 points, depends. So we'll do 2 points. And that's generally if it's a minor arc. All right. 3 points for major arc. And the difference between a minor and a major arc is minor arcs less than 180 degrees, major arcs more than 180 degrees. And we'll go into that a little bit more in a minute. The difference between the arc AB and the measure of arc AB is kind of just how it sounds. So the M stands for the measure, so you're actually getting the degree of the arc. How do you measure an arc? Well, there's many different ways to measure an arc, but an arc is going to be some proportion of the 360 degrees that make up a circle. So the measure of an arc is going to be by looking at the angles. That makes it. Okay, and so example 1 has got a lot to fill out. And so actually what the easiest thing to do to start with would be to fill out over here in this circle. So we're going to look for these missing arcs, and that'll help us figure out what the measure of the arc is. All of these are going to be central angles, so the arcs on the outside are going to match. So this is going to be 42 right here. 64 for this one. And then we have to figure out the other ones. We've got, again, vertical angles between PR and SQ, so this is 42. Makes that 42 degrees as well. We have a diameter here, so it's 180 degrees. And so if we take 180 and subtract away 64 and 42, we're left with 74 degrees. So that makes this 74 degrees out here. Same thing here, we've got 180 degrees running along this line, 42 degrees here, so that makes this 138 degrees. So the outside arc is 138 degrees as well. And now we can just fill in our arc measures now, and then after we do that, we'll talk about if they're a major or minor arc. Again, for a minor arc, less than 180, major greater than 180, and the semicircle is 180. Alright, so we'll start with PQ. PQ we have right here, it's 42 degrees. ST, so we're starting here, going to here, so ST right there, short, small, 74 degrees. Again, minors go that direction. We know it doesn't go around this direction because it has just the 2 letters. So it's got to be a minor angle. So we have TPS, so TPS, so it actually is going to be going all the way around. It's a major angle, so it's going to be bigger than 180 degrees. It is actually 360 degrees minus the 74. So that leaves us with 286 for that one. RT is here and here, so all the way around, passing S. And so we add them together, 74 and 42, we get 116 degrees. QRS, major, sort of, it's 180 degrees, because it is directly on the diameter. QR is right here. We have that as 138 degrees. P starts up here. Q here. S here. So we've got QS, which is going to be 180 degrees, plus the 42 degrees here. So that's 222 degrees. TQR, again we've got 180 degrees running along RP, and then we just have to add in this T, so it's 180 plus 64, so that ends up being 244 degrees. PS, I know it doesn't go this way, because it's just two letters, so it's got to go this way, so it's going to be the 64 plus 74. So that is 138 degrees. And RQS means I'm going to go from R to Q to S. So it's going to be everything minus this 42 degrees. And so for that, we're going to end up with 360 minus 42. So that is 318 degrees. Now we can go back and label them as minor or major arcs, or a semicircle. There's actually only one that's a semicircle. It's right here, and that is 180 degrees. All the ones that are less than 180 degrees are minor, so we have one here, 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 and here. Okay, again, notice that all of these correspond with the two letters for our arc name. And the ones with 3 are our major, with the only exception being the one that was a semicircle. Okay, and that completes example 1. Okay, so example 2, we're learning that a diameter or radius is perpendicular to a chord, and it bisects it. So that helps us figure out some information. So here we're told that CD is perpendicular to OE. Okay, so the E is actually up here. Didn't get printed right. Not right here. Get rid of that. So CD and OE are perpendicular. We know that OD is 15. And we know that CD is 24. So this entire distance here is 24. Okay, and since it says that it bisects it, that means cuts in half. So CE and ED are the same. So that makes it 12. So if we're trying to find OE, mark it as an X. We have a right triangle, so we can use Pythagorean Theorem. So we have 15 squared equals 12 squared plus X squared. And then for that, we end up with 225 equals 144 plus X squared. Subtract 144. And we have 81 equals X squared. The square root will take care of that. So we have X is equal to 9, not plus or minus 9 because we can't have a negative distance. So that means that OE is equal to 9. Example 3 has 3 questions in one, but first let's go ahead and set up what we know. We know that we have a radius of 13, so QP is 13, but so is PS. So we have 13 there. And we have RS is 20. So that's the chord. It's bisected because of the perpendicular. So each one of these has to be half of 20, which is 10. So we're missing TP right there, which is X. And then we can find QT by subtracting 13 and X. So first off, we can go ahead and answer this first question. We have 10 here. We also have 10 here. So RT has a distance of 10. How long is PT? Well, that we have to find that right now as X. And then QT is going to be 13 minus X because the distance from P to Q is the radius, which is 13. So first let's find X. We've got 13 squared, our hypotenuse, equals 10 squared plus X squared. 169 equals 100 plus X squared. Subtracting 100. 69 equals X squared, and we take the square root. You'll notice very faintly here we've got round to the nearest hundredth. So that means 2 decimal places. X is equal to 8.306. So 2 decimal places would actually get us to 8.31. So that's equal to X, which is equal to TP or PT. So we've got 8.31. And in order to find QT, we'll call it Y, we have to do that Y is equal to 13 minus X. X was the 8.31, so y is equal to 13 minus 8.31, and that comes out to be 4.69. And those are those answers. Okay, moving forward, we have that if we have two minor arcs that are congruent, if their corresponding chords are congruent as well. So here, looking at it, we've got arc AB is congruent to arc BC, only if AB is congruent to BC. So this is going to be helpful in terms of finding out some of this other information we have. So first and foremost here, we've got to find the measure of MN. So if these are both congruent, then they're both going to be the same. We have 360, and we subtract away the two that we have. That leaves us with 210 degrees total between these two. And since there's two of them, we have to divide by 2. So that makes each one of these 105 degrees. Finding the measure of AC, we have that this is 116. These are where our congruencies are. So that goes along with these two sides. So we have 360 minus 116. It's 244. Once again, divide by 2. So each one of these is going to be 122 degrees. And here in example 7, since the arcs are equal, the chords are equal, so all we have to do is set those equal to each other to solve. A little algebra. We get x is equal to 7. Okay. Same thing for number 8. We have the chords congruent, so the arcs are going to be congruent. So in order to solve and then plug in, we just set them equal to each other. Okay, subtract 2x. And we can add the 7. Divide by 3. And we get x is equal to 7, and we're going to want to plug that in right here because that's for NL. So 5 times 7 minus 7 gives me a total of 28 degrees there for the measure of NL. All right, finding the measure of arc ABC. So we have this as being listed as 120, so this has to be 120 as well. And so we have 360 minus 2 120s. Leaves us with 120, so that's what x is 120 degrees. And since we're trying to find A, B, C, we just have to add the two together. So 120 plus 120 gives us a total of 240 degrees. Okay, example 10. We have a circle with center y. The radius is 34, so that's going to be this distance from here to here, or the distance from here to here. Those are both the same. So YC, or that, is 34. Then we know that AB is 60, and it's bisected because of the perpendicular line, so each one of these is 30. But we don't know what YD is. Okay, so YD we don't know. We're going to say YD is equal to x right now. And DC we don't know as well, so we're going to say that that's equal to our radius, which is 34, minus YD, which is x. And we'll go about solving all of that shortly. We also know that AC is 71 degrees, and since both of these would create the same triangle, an arc, we know that BC over here, or CB, is equal to 71 degrees as well. AB being the total arc, we'd add both of those together. So we can go ahead and fill these in. We've got 71 degrees here, 142 degrees here. Now we got to figure out the rest. We've already has listed. AD is equal to 30, bisected there. BD is also 30 because of the bisection. And now we need to find YD and DC, which are over here. So we're going to do this with our Pythagorean Theorem again. We've got 34 as our hypotenuse, so 34 squared equals 30 squared plus x squared. And 34 squared gives us a number. Let's see, 34 squared is 1,156 equals 900 plus x squared, so 256 equals x squared. Square rooting gives us an x of 16. So that means that yd is 16, and dc is 34 minus 16, which is 18. Okay, two more left here. Number 11, we got to draw a diagram. We have to find the distance from the center to a 30 centimeter long chord if the diameter is 34. So we've got our circle. We'll say that that is our chord, and that whole thing is our diameter. Okay, so if the diameter, call it d, is 34, radius is half the diameter, divided by 2, that gives us a radius of 17. So just like all of the other ones we do, we can go ahead and make a triangle here of 17. If the overall distance of this chord is 30, and this is bisected, each one of these would have to be half of that, so both are 15. So we're trying to find this, the distance from the center to the chord. So that's x. 17 squared equals 15 squared plus x squared. And 17 squared is 289 equals 225 plus x squared. Subtract 225 from both sides. 64 equals x squared. And we take the square root. We get x is equal to 8, which is the answer. And in number 12, we're trying to find the distance from the center to a chord, and we have to figure out the length of the chord. So we don't know this. We know that we have the distance to it is 6. So this distance from here to here is 6, and we have the radius is 12. So that's 12. And we're trying to find the entire length of the chord. So we'll call that y. But we can only solve for one thing at a time. So we can solve for this as x. And we know that they're the same because they're bisected. So that means y, which is the total distance, is worth 2 x's. So here we end up with 12 squared equals 6 squared plus x squared. 144, 36 plus x squared. Subtracting 36, we get 108 is equal to x squared. We take the square root of that. We end up with a decimal, and we'll round it to 2 decimal places, and we end up with 10.39. And if we want to find y, that just means multiplying that by 2. So that means our distance for the chord is going to be 2 times 10.39. So we end up with 20.78. And that concludes the notes for measuring arcs and chords.